Hi, Dr. R. I heard on SDN that I don't need mass spectra and I just need to follow a study guide.
Whatever you hear on SDN, especially if it's from a student who is up on SDN giving unsolicited advice, just do the opposite. That's my best advice to you. Why don't we look at a mass spectra and I'll show you what you need to know and we build the fundamentals. So come around and I'll show you what we need to do. What I want to do in this example, and I have a few questions in the DAT Destroyer, but I really like this question. I want you to consider a chemical called 2-methyl-1-propanamine. And what I want to do here is to identify two main spikes or peaks. Now, in a mass spectra, what we're going to do is we're going to put this molecule into a machine and we're going to cause the molecule to fragment into many, many different fragments, and those fragments are carbocations. When we make a fragment, the carbocations formed could be a whole different array, from unstable ones to stable ones, but the main spikes or peaks are from the more stable carbocation. The two main spikes that we're going to discuss is what's called the molecular ion spike or peak and the base peak. Now, the first thing we're going to do is we're going to establish what the formula of this compound is. So if you count up, you can see that there's C4, there's 8, there's 11 H's and 1 N. So we get a C4, H11N. Adding up 12 times 4 and 11 plus 14 on the nitrogen gives me a molecular weight of 73. So what I'm going to do is I'm going to fire a very high-speed electron at this, and I'm going to knock out an electron from any possible area. And the resulting species is what we call a radical cation. And that radical cation is going to give me what we call the molecular ion peak. So as you can see from here, the M to Z ratio, meaning the mass, the Z just means charge, the mass to Z ratio is simply the weight of the original compound minus 1 electron. So let's forget that 1 electron and simply say that the molecular ion peak corresponds to the molecular weight of this compound, and it is equal to 73. So on the graph, which I'll show you in a little while up nice and close, we're going to see a spike at 73, and that's going to represent the molecular weight of this compound, or the molecular mass of this compound is 73. Now that we understand what the molecular ion peak represents, we now have information about the mass of the compound. The next spike you're going to look for is the one that's got the highest intensity. We define that as 100, and that's what we call the base peak. That's a little trickier because that's going to represent the mass of the most stable carbocation fragment. So if you go to here, and if you cut this molecule down the middle, you get the structure right here. Now, you might look at this and say, this isn't stable, this is a primary. But think again, you can do resonance. And if you do resonance, you will get a very stable ammonium ion. So if we take the weight of carbon, which is 12, and add 4 H's, that gives me a total of 14, a total of 16, add 14 from the nitrogen, that gives me 30. So the M to Z ratio would be 30. So I would expect the highest peak to be 30. Now, if you come in on this graph, this is what the graph looks like. Notice the most stable fragment, that would represent the ammonium ion, the ammonium ion. So the ammonium ion would be 30, and notice it's at 100. So that big gigantic spike at 100, that's the base peak. And then if you go to the far right, the M+1 peak, that would represent what we call the molecular ion peak. And that will give you the total mass of the compound. So the two main spikes would be the molecular ion spike at the far right, gives you the weight or the mass of the compound. The highest fragment gives me information about the structural integrity of this molecule, where it was in this conformation in which we were able to write out the structure and see that it was the most stable carbocation fragment. I hope this helps. on something that can get very complicated, because sometimes you get other spikes that look crazy and bizarre and you're scratching your head. The only two spikes you got to really focus on are the base peak and the molecular ion peak. All right, that's it for this clip. I hope this gave you some guidance on how to do a mass spectra. Okay, bye-bye.